The new science program has many innovations, one of which is the decongestion of the competences and the arrangement of it in spiral progression manner. In the old curriculum, a specific discipline is being taught per grade level. First year will take up general science, second year will deal with biology, the third year will deal with chemistry, and in the fourth year, they masters physics. But in the new science curriculum program, the different disciplines like life sciences, chemistry, physics, and earth science are being incorporated in every level.
Science curriculum goal aims to help in the development of individuals who are environmentally, technologically, and scientifically literate.
This produces productive members of the society who are effective communicators, informed decision makers, innovative and creative citizens, responsible stewards of nature, and critical problem solvers.
Effective communicators, wherein communication is part of the scientist's everyday life, and this means that they must transmit their messages clearly and concisely.
Last is the critical problem solvers that has the ability to use their knowledge, the data, and reliable sources in effectively solving problems. Next is responsible stewards of nature. That refers to the responsible use and protection of natural resources through conservation and sustainable practices. Another is informed decision makers, which is important to have the scientific knowledge in decision-making process for the society, and scientists should have a mutual responsibility in conveying their knowledge to the public or other people.
Innovative and creative citizen that has the ability in producing new and unique ideas and the implementation of that creativity.
The framework of science education shows that the science curriculum is designed around the three domains of learning science. These are performing scientific inquiry skills, understanding and applying scientific knowledge, and developing and demonstrating scientific attitudes and values. Now let's talk about performing scientific inquiry skills first. This just simply means that the science curriculum is built in such a way that it ensures that every student, every learner will be able to learn the different scientific inquiry skills and will be able to perform them in real-life context. But what are the different scientific inquiry skills? These are divided into three categories. The first one, the basic science processes, which involve observing, asking questions, measuring, classifying, inferring, finding patterns, predicting, and communicating. The second category are the science integrated skills, which involve formulating hypotheses, fair testing, collecting and organizing data, interpreting data, and making conclusion. And the last one are the higher order thinking skills, which are composed of critical thinking, creative thinking, problem solving, and decision making. The second domain is understanding and applying scientific knowledge. Now, scientific knowledge is what we learn from the scientific processes that we perform, which involve experimenting and collecting data. Scientific knowledge helps us develop new technologies, solve practical problems, and make informed decisions. Now, the science curriculum is designed taking into consideration scientific knowledge. It is designed in a way that learners will be able to learn what scientific knowledge is and will be able to apply them to real-life situations. The last domain of learning science is developing and demonstrating scientific attitudes and values. As much as science education focuses on scientific skills and processes, it also gives emphasis towards the scientific attitudes and values. Now, scientific attitudes and values, these are the learner's preferences or feelings towards the science subject. Thus, the curriculum is designed so that learners will be able to develop these attitudes and values and perform them to real-life context. So these scientific attitudes and values involve curiosity, honesty in recording and validation of data, flexibility, persistence, open-mindedness, willingness to tolerate uncertainty, and an acceptance of the professional nature of scientific explanation.
So let's come now to the features of the science curriculum. Science curriculum has 6 features, and these are learner-centered, integrative, evidence-based, culture-sensitive, inquiry-based, and spiral progression. The first feature of the science curriculum is learner-centered, as it focuses on the student's interest. This curriculum design puts a stronger emphasis on the students. Individual growth and development are prioritized in learner-centered design. The next feature of science curriculum is integrative, as it connects different areas of study. It incorporates other subdisciplines such as biology, physics, chemistry, and earth or space science. This kind of approach will help develop the child's ability to transfer their learning to other settings. The third feature of science curriculum is evidence-based, because science program or method is being demonstrated through research to become effective, and it uses relevant information to be always valid in various ways of science teaching. The fourth feature of the science curriculum is culture sensitive, as it acknowledges different cultures of the students. It gives respect to diversity, individual backgrounds, and integrates ideas, customs, and behavior of our society into the curriculum. The fifth feature of the science curriculum is inquiry-based. Inquiry-based science teaching is a method of framing science themes and questions so that the students are motivated to find the solutions by their own curiosity and discovery. The last feature of the science curriculum is a spiral progression. Spiral curriculum is a design framework that will assist science teachers in developing courses and activities or projects that focus on development of critical thinking abilities and attitudes that go beyond identification. Learning science entails growth and consistencies.
The aim of Science Curriculum Guide is to produce scientifically literate citizens who are informed and active participants of the society, responsible decision makers, and apply scientific knowledge that will significantly impact the society and the environment.